When you press the K key on your keyboard, a plunger attached to the key pushes against a spring or a rubber dome. The pressure from your finger overpowers the resistance of the spring or dome so that it collapses. This causes two electrical contacts to come together and electricity flows through them, making a circuit. When you lift your finger, the spring or dome pop the key up and the circuit is broken.
How does the computer know which key has been pressed? The current flows from the key to a chip in the keyboard called a microprocessor. This processor matches the keystroke with a table of scan codes. These numbers are used to identify letters in the alphabet. The microprocessor passes this new code number onto a sort of high-tech waiting room in your RAM. That is your random access memory. RAM holds your letter until the PC is ready to use it. At the same time, the keyboard's microprocessor sends a signal to another device, the interrupt controller. It tells your PC to stop what it's doing and pay attention to the waiting keystroke. Next, the interrupt controller sends a signal to the CPU, which passes the task off to the ROM BIOS chip, which yells up to the keyboard controller, "Hey, where's that scan code anyway?" Based on what key has been pressed, the software performs some action, usually displaying a character on the screen.
A mouse lets you control an on-screen pointer to make menu selections and to manipulate graphics and text on your screen. This mouse has no feet. Instead, a small ball sticks through its underside housing. When you move the mouse, the ball moves too. As the ball turns, it rubs against two rollers and they also turn. One roller senses when the mouse moves side to side. The other roller senses up and down movements. Together, the two rollers can tell which direction you move the mouse.
Each roller is attached to a wheel called an encoder. It turns along with the roller. As the encoder turns, its metal ridges touch two fixed electrical contacts. This sends an electric pulse. The faster you move the mouse, the faster you generate the pulses. The signals from both roller encoders are sent to the mouse's circuitry. By counting the pulses and their frequency, the mouse learns how much you've moved it. Smart mouse! The mouse sends these signals through a cable, its tail, along with any electrical signals created when you press the buttons on the mouse. The electrical signals travel to your PC, where they're read by a piece of software called a mouse driver. The mouse driver now tells your software how to move the pointer on screen so that it matches the mouse's movement. And the whole process happens without any cheese. A joystick does the same job as a mouse, but in a different way. Instead of using mechanical rollers as a mouse does, the joystick uses two electrical resistors that measure how much the joystick is moved. The amount of electricity that can flow through the resistors depends on the position of the joystick. The joystick's fire buttons work just like the mouse buttons, except they're usually more fun.
If you need to get a graphic image into your PC, you can use a scanner. When you click the scan button, a light-emitting diode or LED shines on the image you want to scan. This light is then reflected back into the scanner off a mirror and through the scanner's lens. Special cells then convert this light into electrical signals which are sent back to the PC. You're wondering how a trackball works? Turn your mouse upside down. You see, a trackball is simply an upside-down version of a mouse. The principle is the same, but instead of rolling the ball against a desktop, you manipulate it directly with your hand. How does the monitor work? Signals from your computer's video card are loaded into 3 electron guns at the base of the monitor. There is one gun for each of 3 colors: red, blue, and green. These 3 colors, when mixed together, can create all the colors you see on your screen. Now, these guns don't shoot bullets. Instead, they shoot a powerful beam of electrons towards the face of the monitor. The beams pass through the deflection yoke. It uses magnetism to bend the electronic beams so they can sweep across the entire screen and create the picture we see.
What happens once the beams have swept your monitor? Special chemical phosphors are painted on the inside of the monitor. Energy from the electron beams makes the individual phosphors glow either red, blue, or green, depending on the type of phosphor. The stronger the electron beam, the brighter the phosphors glow. A sheet of metal with holes in it helps keep the electron beams aligned exactly with the phosphors. This is called a shadow mask. The beams sweep across the entire screen 60 times per second. It happens so quickly that you are unaware of the firing process. Instead, your screen appears to be a steady, continuous image, just as it does now. Portable notebook computers use a special screen called an LCD, or liquid crystal display. The screen is made up of thousands of tiny cells filled with flowing crystals. The crystals twist when a small voltage is applied to them. These twisted cells then redirect the thousands of beams of light that make up the display.
Now, most multimedia PCs have a couple of speakers attached to the sound card to provide stereo sound. All PCs have an internal speaker built in, but it's not designed for much more than a simple. External speakers are much better. They contain their own amplifiers and have a control knob for volume. Many also provide controls for mixing, equalizing, and balancing the sounds they produce. Software in the computer tells your printer what text or images to print and where to put them on the page. Inside the printer, a special processor powers on a tiny but precise laser light. A spinning mirror sprays the laser beam in a thin line across the print cylinder or drum. This drum is charged with static electricity and is also covered with a light-sensitive material. Everywhere the laser beam hits, it reverses the electric charge of tiny dots embedded on the drum surface. Each dot is just 1/300th of an inch wide. This charged pattern of dots will soon become a printed page. When the laser beam finishes a single line, the drum turns ever so slightly and a new line begins. Meanwhile, a sheet of paper is pulled into the printer. It passes between two rollers that give it a static charge of its own, exactly the same as that created by the laser, only stronger. As the drum rotates, it passes a bin containing a black powder called toner. The toner too has an electrical charge, but it is the opposite of that on the print drum. Since opposite charges attract, the powder sticks to the drum wherever the laser has charged a dot. Now the turning drum meets the paper. Since the paper has a stronger static charge, it attracts the toner off of the drum. Now to make it permanent, the paper passes through a set of hot rollers that press and melt the toner so it won't rub off or smear. Finally, the drum passes a charging roller which wipes off the old charge, restoring it to its original state. The printer is now ready for the next page.
Laser printers generally use PostScript and TrueType fonts. These are called outline fonts. This is because the instructions for making the font consist of only the shape of a letter, not its size or the pattern used to fill in that shape. This makes the font flexible. Software instructions can tell the printer to enlarge or shrink a character, or to make it boldface or italic, or to change the fill pattern inside the letter's outline. Other printers receive the same types of instructions as a laser printer, but they put ink on the page in different ways. A dot matrix printer has metal pins connected to electromagnets. The magnets push the pins against an ink ribbon, leaving a series of dots on the paper.
An inkjet printer has tiny heating elements that heat a drop of ink so that it expands into a bubble and finally bursts, shooting the ink onto the paper.
A thermal wax transfer printer uses heat to melt wax, colored with inks. Different amounts of red, blue, yellow, and black ink are mixed to create a single full-color image.
A modem lets your PC talk to any other online computer in the world over ordinary telephone lines. How does the modem work? Well, a PC understands only digital data. In other words, code made up of only ones and zeros. But a telephone line uses an analog signal in which modulated wavelengths of sound transmit information, like your voice. That's why the modem exists, to translate the PC's digital data into an analog telephone signal. When you tell your modem software to dial up another computer, the modem opens the phone line, just like picking up the receiver. The modem then dials the number of the other computer using standard tones or pulses. Once the other computer answers, both begin to agree on what method they'll use to send data back and forth. This agreement is appropriately called a handshake. Now, when the other computer is ready to receive information, it sends a clear-to-send signal to your PC. And your PC responds by sending data that sounds like this. That's the sound of the PC's digital ones and zeros being converted into the analog frequencies the phone line can handle. The modem at the other end translates these analog signals back into digital data. Data the remote computer can understand. By the way, if you have a fax modem, it can also translate documents, say like ones you've created on a word processor, into signals that will print out on any fax machine or fax modem in the world.
Most modems have signal lights which tell you what's happening inside your modem. The MR light means the modem is turned on and ready to go to work. The OH light means the phone line is off hook. The CD light means that the modem has detected a carrier signal. In other words, you've successfully reached another computer. The HS light means your modem is operating at its highest speed. The TR light means that your PC, also called a terminal, is ready to work with the data. The SD light flashes each time your PC and modem send data. The RD light flashes each time you receive data. AA stands for auto answer, meaning your modem will automatically go online if someone calls the line it's on.